Okay, so the domain and range of a function. Well, basically, functions are defined. Well, all right, so I guess I better change the color so it's not black. It won't show up on a black background. If you have f of x, some function, and it's equal to, I don't care, anything, 3x squared. Yeah, 3x squared. That sounds good. The domain is the x values that we're considering. The domain would be any of the independent variables we want to choose. So we actually choose them in the case of the problems we were covering in the class. So we choose, I don't know, 1, 2, and 3. So if our domain is the set 1, 2, 3, then our range is going to be the values that this function can be. And just for funsies, let's go ahead and let's make this negative 1, 1, 2, and 3. All right? So if I plug in negative 1 and square it, or 1 and square it, they both give me 1. So the possible values that it can be are 3. 3 times 1 is 3. 3 times 1 is 3. 3 times 2 squared. So there's 3 times 4 is 12. And 3 squared is 9. So 3 times 9 is 27. So our possible values are 3, 12, and 27. That is my range. So my domain is this, and my range, given my domain, is 3, 12, and 27. Even though I picked two different values here, I picked negative 1 and 1, they both spit out 3, there's only 3 values in my range. If this were continuous, this could be any number of things, any value I could plug in, all real numbers say. Then my range would be any number that this could be. Well, if I pick negative 1,000,000, I can get negative 1,000,000 squared times 3. I can pick anything, but the interesting fact of this equation is if my domain was all real numbers, this capital R means all real numbers, and this is basically extra. My range for this function would be all positive numbers. Because if we were to graph this, basically what we would have is we would have a function that comes down, hits the x-axis, and comes back up. It can get as big as you want it to be. There's no limit to how big this thing's going to get, but it'll never be negative. It will never be down here. And pardon the princess and the frog in the background, Zoe really likes.